And now I'm gonna give the stage to Dávid, our first real technical speaker. So please welcome Dávid.
Hi guys, I am David and I'm a developer. I've been programming in Python since 2010, I believe, so it's now 8 years. And today I am trying to create a very experimental kind of code. So I will not have a PPT. Can you hear me all the way back there? Alright, great. So I don't have a PPT. I'm going to do my whole presentation in this terminal. And what I'm going to talk about is something that is not really intuitive about Python. Python is a very intuitive language. It's just like English. You can just go at it and program, and it's pseudocode interpreted. But it doesn't really have a clear handling of copies and references. And if you are not clear about what I'm talking about, in many languages you can actually specify if you want to use the data that you have created in its place in the memory, or if you want to copy it and work on a copy. When you are working on a copy, you actually have the data twice, and you don't edit the original data, you only edit the copy. When you are editing the original data, that can change. So both have their places in programming, and in some lower level languages such as C, C++, I believe C#, you have to handle your own memory, and you are very, very, very aware if you are working on a copy or not. In Python, not so. And this is all documented. I'm not going to say anything new, but this is something that I usually forget, and I guess that's good for that. So the tools I'm going to use today is the is and the equal operator. The difference between the two is that this is actually true. This is also true for some reason. But this is actually false. So why is that? Actually, this is a number handling thing in Python. I'm not going to go into it because it's very technical. But the thing is that equal actually checks the value of what is there and the object that is there. And 1000 is actually equal with 1000. But our two 1000s are in different memory locations. And in C Python, we can check the memory location by saying ID A and ID B. And you can see that we have gotten different numbers there. So really what the is operator does is checks the ID of our A and the ID of our B. And checks if they are equal. Yeah, so this will be our tool today. I'm trying to clear. So first of all, I want to talk about dictionaries. And dictionaries are the biggest offenders about this. This is, by the way, not my computer, so that's why I don't know what is where on it. So, dictionaries are the biggest offenders when copies and references are considered. Because if you do this, and then you make B equal to A, then you will see that A is actually B. And if we have some kind of content in our dictionary, then if I am changing anything in B, it will be also changed in A. I'm looking for the brackets actually.
Okay, I can be your
I'm
assistant.
not familiar with this. Yeah. So where is it? So if I am changing this one to 2, you will see that A has also changed to 2. And this is something that we usually do not intend to do. There are some times when we just pass along one dictionary and change everything and then nobody knows what happens there. But we have a great library, it's built in. It's called Copy. And if I'm actually copying B, then if I'm changing anything in A, that won't change there. And you can see that it actually got a different memory address. In the first case, so if I'm making B equal A again, you can see that B is actually A. Alright, and this is all good and nice, but something that goes wrong every time is when you have a dictionary. Inside the dictionary, it would be intuitive if copy.copy just copied everything there and we would be done, but it doesn't. So if we have something like this, and sorry for the confusing variable names, I'm not really creative today. Then if I copy this to, let's say, B, and I change anything in the embedded dictionary, I'm gonna get the hang of it. Then it actually changes in A. We also have a function for this, so it's copy the copy, and then everything is cool. Yeah. Actually, you might try to implement the copy. It's a really fun afternoon exercise if you are bored. But what is extremely interesting that you can actually stack the same dictionary in itself, like so. And deep copy actually handles this. See this. If you would just start recursively reading this dictionary, this would take forever, literally forever. But copy.deep copy actually makes a proper copy of this too. Yeah, so the same is with lists. Lists are also not copied when they are reassigned. But this is basic stuff. This is actually in the documentation of Python. Something interesting that I came about one time is that I tried to use a format which is also in a lot of tutorials. I'm looking for the multiplication sign.
Sorry.
Yeah. Alright, so you can actually do this in Python, it's pretty cool. You can actually do this with literally any kind of container, so if I would do this with a list, then this would return an empty list, but if I actually put something in the list, then it will return a list with 3 of that stuff. Now, the interesting thing about this is that this doesn't copy the thing that is in there, it just copies the reference. So if I were to do something like this, which I actually done once, to instantiate a list of lists, then I get a list of lists. But if I try to add something to one of the lists in our list of lists, then it will go into all of them. And if I remove something, it will remove it all of them. If I delete one of the lists, it will delete all of them. So it's just a complete mess. There is also a solution for this. You can either write a loop and just fill it normally, or you can do this in a very nice and Pythonic way, which is called a list comprehension. It looks like a list, but it actually is a loop. It comes from Haskell, I believe. And this returns 3 very distinct lists. And I can show you that if I assign this to somewhere and then just put something in the first one. Then it is actually in the first in-text element. Yeah. So this is the useful part. The useful part ends here. So I've shown you something about numbers in the beginning, which I believe is pretty cool. So if you say that A equals 1 and B equals 1, then A is actually B. But if you say that A is some big number and then B is also some big number, then A is not B. So the point of inflection is somewhere between 200 and 300, and if you are if you know your basics, you will know where it is. So 256. Yeah, it's all right. And that's not cool. So really, don't use these when you should be using equal. Same applies for JavaScript, where you are using equal and equal. So it's super easy to mistype it. Literally happens every time. Yeah. So also something completely useless that I wanted to show is that you can't copy everything. So there's only one none. If you check the ID of none, then you will see that it's put some memory address. Actually, in the past, I believe somewhere in 3.4 or 3.5, you could overwrite with all kinds of arcane memory editing techniques, none, true, and the number constants, and it would produce all kinds of zany things. I can't show you this today because in 3.6 this causes a segmentation fault and just completely quits the interpreter. But if you try to copy none, And I'm not going to assign this anywhere. I just want to show you that you can ID anything, even if there is just one reference to it. You will see that it is the same. And I just did the mistake that I said not to make. So it will be completely the same. Actually, the same goes for any number below 257. But you can copy numbers above 257. This is an oversight. If there is a core developer here, please fix this. Wow. Well, that's interesting. Actually, I've tried this whole talk before on my work computer, which is also a Mac, and this actually produced false. So either we are behind one version or above one version, and this has been fixed. Wow, this is pretty cool actually. Alright, that's pretty much what I wanted to show you and tell you. And if you have any questions, then please don't hesitate to ask. Yes?
Is this a bug that the numbers below 256 are equal and above are not equal, or if you put the is?
No, this is an implementation detail. You should never use is somewhere where you are not absolutely sure that the data will be on the same memory address. So we are usually using none is none because there is only one none and none can't move anywhere during the execution. But this isn't a bug, this is an implementation detail. So it's very intended, but funny, strange. Thanks.
Could you try none equal equal none? Let's see, none equal equal none. Okay.
It's actually
And could you try 257 equal equal 267?
All right.
The same.
It actually is. But only because when we are doing this in one line, then we instantiate an instance of the number 257, and then as we have a reference to it, we just reuse the already present 257. So that's why if we are in an interactive session and we are assigning it to some kind of variable, it will not be the same. Yes?
Do you have any cool stuff about true and false?
True and false. I could actually override true and false.
Let's see.
I can no longer override. You can actually try out this library. I can really recommend this. This is called C-types. It's officially used for accessing DLLs on Windows, but it can be used to rewrite everything in Python, or it could have been used in 3.4 and 3.6. You can no longer do it. Yes, sadly. But true is true. So.
You can try true is one.
True is one.
True is one.
Yeah, true is one. Yeah.
True equals one.
Actually, this is false.
True equals one.
Yeah.
It's
Yeah, that's true. Actually, this is another implementation detail. This is because true and false, the booleans, are actually subclasses of the integers. So really, true is just the one that is dressed up fancy.
Can you give us a practical example of usage of is keyword when it is absolutely necessary?
I cannot give you an example where it's absolutely necessary. It's good practice to do none is none. The magic of life.
But beside this,
But actually, in the past I have used is to check if something actually is the same object. In case of loops, where I will change everything around that I didn't know what actually came out of the function. This is a very specific subcase of a subcase, so I'm not sure if you will ever.
so you can turn the whole thing into ID and equals.
Yes, absolutely. In C Python.
Yes.
So this is very important that ID actually returns the memory address in C Python. It doesn't necessarily return the memory address anywhere else. But ID of something equals ID of something else is equivalent to is in PyPy2. Yes?
Can you tell a few words about the relation of Python and C Python? Because I don't know much.
Yeah, absolutely. So C Python is the reference implementation. If you are starting out Python and downloading the interpreter, there is a 99.9999 chance that you are using C Python. Actually, after this was implemented, people implemented Python in other environments. And there is a Python interpreter completely written Python, which is PyPy. PyPy is pretty cool because you can just move around everything in Python, so you can write the whole interpreter in Python. And it is actually said to be faster, but in some situations it kind of is. If you can access a C library, then PyPy will not be faster than C Python will be at the C library. In many other cases it will be. Done?
Okay, no more questions?
Sorry, can I have a question? Do you happen to have NumPy installed?
NumPy. Actually, this is not my computer. I didn't want to plug it there on, but
You can try, maybe, yeah. I don't know. I don't think so.
With small. Okay. Doesn't matter.
We can install
yeah,
it.
NumPy has some.
Might take 10 minutes to install it. It's a pretty big module.
It's
Yeah.
fine. We need 10 minutes for the pizzas to come anyway.
Yes?
And just a beginner question, when someone would use none is none, I mean, this is always true. So why do you use it? Because if you say, why don't you use it is or true or...
Yeah, well, let's say you are instantiating or initializing, sorry, words here, initializing a variable before you are going to work with in a loop. So, and you are initializing it to none. Yeah. And I'm just going to show it first and then speak because I can't type and speak at the same time. Sorry.
Don't give up.
I'm looking for a relation sign. Ah. So this is this is a very educative case. So this will you will never write code like this. But you sometimes have to instantiate a variable before a loop. And in these cases, it's good practice to instantiate it to none. And if you want to check if the loop was actually doing anything, so if you have a result, Then you can do a is none, and you will see that loop didn't do anything. You can also do this in cases where you don't know if there will be data there. So, for example, you are parsing an XML file, and you are not sure about the text that you have in that XML file because there might be some missing. And you can check it with, and LXML will actually return none for those tags that are not present.
And just one little question. And if I initiate it like none, then I can use it in either way, like as a string, as a list, as a dictionary, or is it fixed?
You can change it to anything.
Okay.
So really, the variables are not actually fixed into one type. You can just switch them around.
Okay, but if I have a loop and I want to populate it as a list, and before I initiate
I see.
will receive an error or not?
No, you can't. So you have to instantiate it as a list.
You mean initialize? Or instantiate or initialize?
Initialize. I'm sorry.
What's the difference?
Instantiate is when you have a class and you are creating an actual instance of that class. Initialize is when you are setting up some variables that you will use later but not using right now. I constantly mix them up. Yeah. Also, one more technique that you can use to avoid stupid mistakes like changing originals that you don't want to change. Use tuples instead of lists. So you can see that if I instantiate some kind of initialize. I'm not going to say these words. Some kind of tuple. Then if I want to change this tuple in any kind of modifying way, then it just won't work, and even if I am assigning it to a new variable, then it will just say that this is not supported. So this is one thing that you can do if you want to avoid messing around with your lists in your functions.
Okay, no more questions? Awesome, cool stuff. Thank you, David, so much. So I just saw that it's a guy walking. Perfect timing. We're gonna have a break of half an hour. Depends on pizza how quickly you can eat it. And then we have some beers in the back, some water, and if we run out of it, we can always get some more. So just let us know. And then after the break, we're gonna switch to Hungarian, and we're gonna have the 2 Hungarian talks. And so this means, so you have time until 8:15, and I think if you're smokers, then you need to go downstairs to smoke, I think, but then you can come back, you can just ring the bell and come back. So yeah, have a good pizza.